Hello, my name is Andy Schweitzer, and this is a quick little video on um, what's called advanced factor label. Now, factor label is simply just a relationship. It's a linear relationship. So, factor label is just another way of doing proportions. A proportion is the main gear, and we'll frame it in the form of what's called a factor label. Just so what makes it advanced is that you might do several proportions in a row, and again, I'll do them in the framework of what's called a factor label. But you may be asked to do several proportions in a row or several factor relationships in a row, which can make it more difficult. But really, it's the same thing. Or you might be asked to do it about some topic which you're not as familiar with, or which makes the topic itself might seem a little bit more complicated. But if you look at the units and you keep track of your units, canceling one item for another, you can often do calculations that are quite complex and often very useful. So our first example of this, and these are non-chemistry examples, and later in this video I'll do an example of something involving chemistry. But at this point, something simple like $10 per hour. And this is a relationship. So if someone said to you, okay, you're making $10 per hour, how much money did you make? All right. Well, I have no idea. How long did you work for? This is the same thing if someone says you're traveling at 55 miles per hour. How far did you go? It means nothing. You could travel one city block at 55 miles an hour, or you can travel all the way across the country at 55 miles per hour. Two totally different things, but at the same rate. So if someone works at 40 hours at 1 hour as $10 per hour, this is my relationship, you make $400. Okay. Now, if you're making $10 per hour, and let's just say you want to make over the course of the year, notice my units cancel hours to hours. This is my relationship. Want to make 50 grand in a year. Okay, $50,000 per year. Now, in this case, the year stays. I'm not going to change the year. But how many hours would I have to work if I'm making $10 per hour and I want to make $50,000 a year? Dollars cancels, and I go to hours. Now, in this case, notice that my relationship is backwards. It's upside down, reciprocal. So, how do I know the 10 goes in the bottom? The dollars cancel, dollars to hours, and 1 hour equals $10. So, your units are in the right spots, and make sure your relationship makes sense. You're equal. Either way, 50,000 divided by 10 equals 5,000 hours. I don't even know that's possible to work $5,000 hours in 1 year. Okay. Either way, another example, okay, involving what I consider a little more advanced problem, which isn't any more advanced than before. It's just a different scenarios. Would be, let's say you're traveling from Appleton to Milwaukee, and that's about 100 miles, okay? Driving a car that's getting 30 miles per gallon, and the cost of gas is $3.20 per gallon. How much will it cost you to drive down for this particular ride, okay? Now, these are conversions, the relationships, and this is the only real hardcore piece of data. So in this situation, I am going to first make a bit of a plan, just like I would in any other problem. I'm going to take my distance. I'm going to convert that to, distance is here. So really, of my conversions, without having any knowledge of what's really going on, you could say, well, distance miles, I have to use these miles to convert to gallons. So I'm going to convert distance to gallons using this relationship, and then convert gallons to dollars using this relationship right here, knowing that I can flip these, reverse them around, and get them to line up so that the units cancel out, giving me dollars in the end. All right, so we'll take our 100 miles, dot line, get rid of miles. This is the way I like to do it. Go to gallons, get rid of gallons. Now, if I stopped here, it would tell me the number of gallons that it requires to drive to Milwaukee. Get rid of gallons and go to dollars. And this is going to be two relationships. Make sure you get top and bottom correct. It is 30 miles per 1 gallon. So 1 gallon is 30 miles. Very common to get this backwards, but if you're canceling your units constantly, miles cancels, gallons cancels, and you'll get the right scenario. Dollars per gallon is $3.25 per 1 gallon. I have that on there already, but either way, take your math calculator. I'm going to take 100 times 1 divided by 30 times 325 divided by 1, and you will get $10.83. to drive to Milwaukee. Again, this is just an example of using factor label or proportions, same thing, to get an answer. Look at where you are, look where you want to go to, look at the conversions that are available. Okay. Quick example of this in terms of a chemistry situation. Okay. Again, this gets a little bit more abstract. Okay. Let's say, for example, we have 200 grams of silver nitrate. Okay. And I want to know, of that 200 grams, how much silver is involved there. Okay. So we have done in the past percent composition of various items. Okay. And I'd say, okay, well, this guy has a mass for silver nitrate of silver is 107. This guy weighs 14. This guy weighs 16. And this is in grams per mole, or AMUs. And there are 3 of them for a grand total of 48. Add all these things up, and it is 169 grams, okay, or AMUs per molecule. Now, in this case, percent by mass, equals what percentage of this stuff is silver? 107. For the total mass is 169. This equals times 100, my percentage. Now, 107 divided by 169 equals 63%. So 63% of this thing is going to be silver. So I could simply use a proportion, okay, which would be 107 over 169 equals, and then of the total mass, 200 grams, this is total. This is just the mass of the silver. So I want to find the mass of silver in 200 grams, cross, multiply, and divide. Equals, again, we're using proportions here, is 126 grams. All right, so I could do something similar to this using factor label, 200 grams. And this is grams of total to grams of just silver total. And this is going to be 169 to 107, and you'd get 126 grams. Okay. Another example of this, okay, might be something as simple as saying, okay, for silver nitrate, AgNO3, each individual particle unit here is 169 grams. Now, it's 169 grams per what we call 1 mole. This is the number of particles. Or you could say 169 AMUs per 1 particle. Now, in this sense, this is how much one weighs, this is how much a large number of them weighs. Okay, so I could say that if I have, let's say for example, 50 grams of AgNO3, or I could say 50 AMUs. Okay? Either way, this is using a relationship. How many moles of particles? And this is like actual number of individuals. This is something that we have yet to really discuss, but again, it's just using factor label. A mole is number of particles. This is a mass. This is number of particles. So I would say 50 grams. Get rid of grams and go to moles. And I would simply use this conversion. 1 mole weighs 169 grams, and I would simply divide. Now you should note this is less than 1. 1 mole weighs 169, so I have less than 1 mole. 50 divided by 169 equals 0.295 moles. Mole represents number of particles. And since 1 mole weighs 169 grams, then I have 0.295 moles, regardless of whether you at this point even know what a mole is. Okay? Advanced factor label. Good examples in chemistry that we'll be using quite a bit throughout the year.